This one says, you and a friend get into spaceships which are identical when docked at a space station. You later fly past each other at a high speed. Now, at the moment your friend measures his ship as being 20 meters long, as you're flying, your friend measures his ship as being 20 meters long, but he measures yours as being 15 meters long. So, what's being described here is the phenomenon of length contraction. And it is another relativistic phenomenon. One of the phenomena is that time can be stretched, but another phenomenon is that length can be contracted. So we'll have what's called LO, which is proper length, and L prime will be a contracted length. Now, I did a video explaining why length contraction occurs, but the relationship between proper length and contracted length will be as follows. It'll be LO equals gamma times L prime. Remember, gamma is going to be 1 or larger. So that means that the proper length is going to be the longest possible length. All right, so your friend's on his own ship. Okay, what he's saying is when he looks at your ship, he thinks that it's shorter than his own. He measures his own to be 20 meters. But he thinks that your ship, L prime, measures 15 meters. Okay. So, when he measures his own ship, that is a proper length, because he's in the reference frame of his own ship. When he measures your ship, what he'll be measuring is a contracted length. All right, so how long is your ship according to you? Well, this is his perspective. This is the friend's reference frame. So your friend is at rest relative to his ship. Now let's draw your reference frame. According to you, you're not moving in your own frame. So you think that your ship is exactly as long as it would be when it was at rest. You think that his ship is short. So there's the friend, and there's you. So you'll measure what's called L naught, which would be the proper length of your ship. but you'll simultaneously think that his ship is now short. That's the idea. Alright, so how long is your ship in your reference frame? You believe it is 20 meters, which is L naught. How long is his ship? You'll think his is 15 meters. What is the actual speed of his ship? To answer that, we want to use gamma. Gamma equals 1 over the square root of 1 minus v squared over c squared. But right now we don't know gamma and we don't know v, so we have two unknowns. So you'll want to use this formula over here to find gamma. So plug in the proper length of the ship, leave gamma as a variable, and then plug in the contracted length of the ship. Gamma comes out to be 4/3, which is about 1.33. And now we can take that and plug it in to the formula for gamma so that we could eventually solve for v, the relative speed of these ships. Alright, so we just have to solve that using algebra. Okay, we get this, square both sides. Subtract. So v squared equals 7/16 c squared. Therefore, we get 0.66 c. Approximately 66% of the speed of light. That is the relative speed. Relative speed between ships is approximately 66% of the speed of light.